SN1. So we know that SN2 reactions are favored for primary alkyl halides. We know that SN1 are favored by tertiary alkyl halides. We know that secondary alkyl halides can kind of do both, right? Secondary alkyl halide can do SN2, but it can also do SN1, depends on what the conditions are. So remember, really good nucleophiles, things that are negatively charged, favor SN2. Solvents also favor SN1 and SN2. So if you have a polar aprotic solvent, that's going to favor which reaction?
SN2.
SN2. Polar protic solvents favor SN1. Okay, so you always got to pay attention to the reaction conditions here, and then you got a whole list of that in your book as well. So we learned that we can take alkyl halides. So if we think about a variety of different SN2 reactions, so you can react with like cyanide. So there's a whole list of nucleophiles that I gave you in the slides. We learned that we can use alkyl halides plus hydroxide to make alcohols. We can take alkyl halides and we can react them with acetylides. And make new carbon-carbon bonds. I think we talked about using azides in 3-, and we can make new azides. So there's a whole list of things that we can do for SN2 reactions. The thing that's common here is all of these nucleophiles are negatively charged. I'm assuming that these are all primary alkyl halides because I haven't said otherwise. And you know that primary alkyl halides can only do SN2 chemistry, right? Because you can't get a primary carbocation. Secondary alkyl halides, however, a little different story, right? Things can go either way. So let's look at an example where we have something that looks like this, maybe. Let's just do that. And let's say I'm doing this in some kind of polar aprotic solvent. One of them that you learned about was called DMSO. So I'm doing this in DMSO. It's not my favorite solvent. I hate it, actually. It's hard to remove. But it does favor SN2 reactions. So what's the product going to look like? Can it? You tell me. That's the whole point of my question.
Well, it's got some stereochemistry to it, right? So it's either an R or an S.
Okay, that's right. It's either going to be, or I mean, we know what the product is, right? That's the R enantiomer of the starting material. Excuse me. Right. Now think about it. If the oxygen with the negative charge approached from the same side of the molecule as the bromine, would that be favorable? Why not? I drew those electrons in for a reason. Are electrons going to want to be next to electrons? No. So this bromine has all these lone pairs of electrons around it. It's not going to, the methoxide or the O- isn't going to approach from that side. But it's going to approach from the back side, right? Remember, SN2 reactions, the nucleophile comes in from the back side. So imagine this coming in from behind the board, and that leaves at the same time we're forming the new carbon-oxygen bond. And so when I do that, right, that's going to push the hydrogen out in front, and it's going to put the OCH3 behind the plane of the board. So what happened to the stereochemistry? I went from R, what is this now? S. SN2 gives you complete inversion of stereochemistry. SN1, what happens if it's an SN1 reaction? Now it can approach from either side, right? Because the leaving group leaves and gets out of the way, and you get that carbocation. And then the nucleophile can either attack from the top or the bottom, and you can get what kind of mixture?
Racemic?
Racemic mixture, that's right. So, one way to know whether or not a reaction is occurring by an SN1 or an SN2 mechanism is to actually run the reaction in the polarimeter. So you start off, this rotates plane polarized light, let's say in some direction, right? I don't know what direction it really rotates in, this particular molecule. But as the reaction occurs, the configuration changes, right? So what's going to happen? Is it just going to stay steady? I'm probably going to see it start to move and rotate plane polarized light in the opposite direction. It's not going to remain steady. Now, if I ran this reaction instead of methoxide, which is negatively charged, let's say I use methanol as my nucleophile, and I also use methanol as my solvent. Now this is a polar protic solvent. Polar protic solvents also favor what reaction? SN1. So what would I expect the product to be then? I would expect the product to be a mixture of this and this in a 1-to-1 ratio. Again, because the nucleophile can attack from the top or the bottom, right? 50-50 chances.
You said that since SN1 makes 2 bonds.
It makes both enantiomers in equal quantity.
Yes.
Yes.
In that video you guys watched, so you said 1 is 2 and 2 is 1. Right? You said something like that. You said something like that.
Well, there are steps. This is a 2-step process.
Yeah.
Even though it's SN1, it's a
I
2-step
was just wondering
process.
if like that's applicable.
Sure.
Okay.
Yeah. I mean, you have to have the second step, right? Or this doesn't occur. And the fact that this goes through a carbocation intermediate is why it's racemic. That's right. So this would be SN1, and it is 2 reaction steps. I'm not showing them here, but this leaves first, you get the carbocation, and then you get the product. The product turns out to be racemic. Okay? And so, you know, Colton, if you did this reaction in the polarimeter tube, your starting material would rotate plane polarized light, but as that starts to get formed into product, since the product is racemic, it would start to just go to 0. And once the reaction is completed, you would not see any rotation of plane polarized light anymore. That's actually how they determine SN1 or SN2 type reaction. They can measure the polarimetry of what's going on. Run the reactions actually in the polarimeter tube. And watch that. I'd pay attention to table 7.5, which is on page 205 of your book, and the tables on page 204. That's where you've got a list of your protic and aprotic solvents. Those would probably be good things to have in your notes.
Can you repeat the page numbers again?
204 and 205. Pardon? Yeah, well, there's 7.3, 7.4, and 7.5 in the tables. Yeah. Haloalkanes can also undergo eliminations. So if I took this molecule and I treated it with potassium tert-butoxide, we're going to undergo an elimination. This is what we call a non-nucleophilic base. It doesn't function as a nucleophile because it's big and bulky. The tert-butyl group, as we call it, is big, and it really shields the oxygen. So it can only really react with small things like hydrogens. And so what happens is we get an E2 elimination, in this case, where the tert-butoxide abstracts a hydrogen, the leaving group leaves, and you just took a really expensive starting material and made a really cheap product and got fired, right? So this is the E2 elimination. These can also undergo E1 eliminations because they're secondary. So maybe I put it in water, heat it up to 100 degrees Celsius, boil it. That will undergo elimination. Remember, high temperatures favor elimination over substitution. So when you're starting to talk about, 75, 76, 100 degrees, 120 degrees, whatever, well above room temperature, eliminations occur over substitutions. And in fact, if you take this and put it in water at room temperature, that's what RT stands for, what you'll find is that you'll get the substitution product. It'll be racemic, of course, because it goes through an SN1 reaction. Why do I know it goes through an SN1 reaction? Because I've got a polar protic solvent and a very poor nucleophile. It's not charged. So it's going to favor an SN1 process. Okay? So lower temperatures favor the substitution, higher temperatures favor the elimination. We know that the halogens can also be thought of as leaving groups. What do we know about the leaving group ability of the halogens as we go down the family?
Get better.
Gets better, right? Fluorine is terrible. Chlorine it'll work. Bromine's pretty good. Iodine is really fast. So as you go down the family, the leaving group gets better. So if I'm doing a reaction with an alkyl iodide and an alkyl chloride, I would expect the alkyl iodide to be faster. And it's going to be faster whether it's E1, E2, SN1, or SN2. All reaction mechanisms are favored by better leaving groups, right? So, remember the little demonstration I showed you the video of, right? That was between tert-butyl chloride and tert-butyl bromide in water. And you all saw that the reaction is about, what did we calculate? About 8 times faster or 8 times slower, I should say, for the chloride over the bromide. The bromide was done in about 30 seconds, and the chloride took 2.5 minutes or so, something like that. Yeah. Took a while. All right. That's chapter 7. Chapter 8, we'll get to whatever we get to on Monday. My best guess is we will not make it past, let me see here. We will probably not get much past 8.3. We didn't get very far last. We might make it past 8.3, but we won't get to it. Well, I could.
Yeah.
The examples that we've done in class 4, and the last 2 you didn't name them. You named the first 2, but then the last 2 you didn't name.
I mean, I didn't name.
I don't know. You said you were only going to name the first 2. It was I have them written down, like drawn out, but you just, I don't know if you were just trying to move on, or whatever. But I know we went over those 2, but these 2 I wanted to know. I named them right.
Oh. 2-methyl, 1-cyclohexanol is correct, but you need to call it trans.
Okay.
And you're going to have longest chain containing that, right? That's yep, you did. That looks good. If those are, I don't remember if those are exactly the molecules, but I'll trust you. But the names that you have there are those molecules. Okay. Yeah. Other than you need to call that one trans. So since we haven't made it very far into the alcohols yet, there's not a whole lot of point in going through a lot of it, other than to talk a little bit about, you need to remember that there's a rule of solubility, right? So alcohols are going to be soluble in water if and only if what?
Less than 5 particles.
Per OH. Right, so if I have this alcohol will be soluble, this one will not. Right? So we look at this, I've got 3 carbons and 1 OH, that meets my 5 carbon rule. This one has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 to 1, that is not. In fact, you can take that alcohol, put it in water, and you'll see 2 layers. It won't mix. You take isopropanol at home, you mix it with water, it's one homogeneous. Okay? Naming alcohols, the OH is a privileged substituent. What's privileged about it? It gets the priority. You want it to have the lowest number in the, so the parent chain must contain the alcohol, and you want that alcohol, you want to use your numbering system such that the alcohol has the lowest number you could possibly get. Okay? And then using the normal rules for everything else that you know about. Okay. This exam will not focus on naming as much as the first exam did. There may be a problem or two, but there won't be as many naming. All right, well, whatever we get to on Monday is where we'll finish up. And that's what we got for the exam on Wednesday. I won't be there Wednesday. My wife's going to administer the exam, but again, it'll be the same as the last exam. You'll get, well, I didn't tell you, but you'll also get a periodic table, so you'll have that again.
Did you say your wife?
I think so. She's just going to administer the exam. She's not.
Be silent the whole time.
I will not have it graded before next Monday because I get back late Sunday. But I will get it graded and back to you as quickly as I can.
Do you have any practice exams?
I don't have a practice exam for this one. I looked through my old exams and everything that I had on chapter 2 or on exam 2 last time just wouldn't have fit. This is just, the class is ordered so much differently than the last time I taught.
We can find a bunch of problems that be similar to this, like specific ones in the book that you can do.
I would recommend in each one of the sections that you go back and look at all of the example problems that they work out, and try each and every one of the ones that they don't give you the exact solution for right there. That would be a good place to start. And then any place where I have told you, you know, for example, when we go to chapter 7. So, you know, I gave you a list of problems, right? So, for example, I gave you 716, 717 as just an example. And those are all under this section 7.2 to 7.6. But there are 3 or 4 other problems within that section that you could, I mean, that are related. So anything that's close to one that I assigned would be a fair one. Would be a fair thing to help you out with.
My marching band just finished competition season.
So why am I lucky about that?
Because I now have time to study.
Oh, I think you're lucky.
You're the one saying you're lucky because you won't see a zero, maybe.
Well, I didn't see a zero the first time, did
You'll be surprised.
Was the redo option only available for exam 1?
What if we want to do the wins? What if we put in the extra effort? Should we get awarded?
I? Well, remember what I said in class, that if your final exam turns out to be better than your overall class grade, I will give you the better of the two.
So what if our final exam isn't better?
Then, well, you get the better of the two, right? So if your final exam is worse than your overall class grade, then you get the overall class grade.
Gotcha. Okay.
So if you have an overall class grade of an A and your final exam was a B, you get an A. If your overall grade is a B, but you did really well on the final and you got an A, I'll give you the A from the
Have you
final.
had people get A's on the finals before?
Sure.
Once in a blue moon?
No.
I just go.
I have a question about the worksheet that we did. So this bottom answer is the one that you provided. I'm not sure, like, how would I know that the bottom answer that you provided is correct compared to the one I did?
Well, remember, you've got other substituents here, and you want all of your substituents to have the lowest number, and bromo, the halogen has no priority like alcohol. So when you name it the way you did, you ended up with the higher numbering system for all of your substituents. That's how that is.
Thank you.
Yep. There'll be a little bit of naming on this, but not a bunch. What else is there?
Can you give some examples like for the what's the name of it? Like the specific rotation questions, like when you give us the option to solve for something that isn't simply the specific rotation?
Yeah, so.
Like if we had to solve for the concentration.
Yeah, so let's suppose, I don't know, let's suppose you've got a sample of menthol. And I don't know what these numbers are, I'm just gonna make this up, okay? It says it's some stuff out of the literature. Well, let's say that we know that the specific rotation for that is plus 10 degrees. And you take a solution that you were given and you observed an alpha of 1.1 degrees. And the polarimeter that you used had a path length of 1 decimeter. What's the concentration? The concentration is in grams per milliliter. Right, so what I would do is I know what my equation is, right? I know that the specific rotation is equal to the alpha observed divided by the path length times the concentration. So I can rearrange that to where my concentration is equal to the alpha observed divided by L times the specific rotation. Right, so all I gotta do is plug and chug. 1.1 divided by 1 times 10. So it's roughly 1/10 of a gram per milliliter. I could ask you, I could give you what the concentration was and ask you to solve for the path length. I could be L.
So the answer is just, whatever 1.1 divided by 1.10 is?
Oh, that's.
Well, no, that's times. That's not one. See, L times. L is 1, so 1 times 10 is just 10.
Oh, yeah, okay, so, but still, whatever that product is,
Yeah, so it would be 1.1 divided by 10.
which is 0.11.
0.11 grams per milliliter, yeah.
Are you gonna get us, as you did in class, where we had solved for grams, or are you gonna just, you're just doing that?
It's fair game. Haven't decided what.
Yeah, that's not that bad.
But if you wanted us to solve for grams, you'd have to give us milliliters.
Oh, yeah, you'd need something else.
Yeah.
I mean, if I gave you, if you had a liter of solution or whatever,
And then-
you could take your concentration grams per milliliter, take it times 1,000, get the total grams. Read those types of questions very carefully. Know what it is that's important, what's not important. Well, I might tell you a little story. Might make you a chemist. And then they're doing something, right? So, but what's important? And this is really, if you were to go to the sugar factory in New Orleans, there is a sugar factory there. I mean, this is how they measure the purity of their sugar. They make up a solution, they put it in a polarimeter. The path length in sugar chemistry is a little longer, but for whatever reason, I don't know why they defined it that way. And they measure the rotation and they determine how pure the stuff is coming out of the sugar cane. It's just chemistry. This was one way actually in which you could determine blood sugar concentration back in the day before you had diabetic strips.
Thank God for technology.
Yeah. The thing is, you had to give a lot of blood. You had to precipitate all the proteins. You had to get rid of the red blood cells, and then you could measure the rotation of the remaining blood sugar and get an estimate of what your blood sugar concentration was. Now you just prick a little finger, put a little dot, put it in a thing. and what it is. But I could take 100 milliliters of every blood, spin down the cells, precipitate out the protein, take the remaining plasma, take a rotation. What else? All right, so we'll have another session up here tomorrow, 5:30 to 6:30, I think is what I sent out.
Yeah.
So if there's anything else that you all want to come and ask questions about before the exam, especially as it relates to the material we cover tomorrow, I'll be right here.
Quick question. Will there be any hydroboration?
It's fair game. We covered it, right?
No, that's kind of scary, but
I don't remember, what did he talk about? What did he say? I think I've had a nightmare when you I think I was in class and I was like crying.
Doesn't make me feel very good.
I was just stressed out.
But it's true.
I had a nightmare about my boss last night.
You're what?
Boss, because I didn't get on the bus and he's like, where are you? He called me. I had a nightmare about him saying he was going to fire me because he couldn't find me. Because I told him I was leaving.
Okay.
And like my nightmare was very scary.
Focus on the basics. I'm about halfway through getting the exam ready. Got to wait to see how far we get tomorrow to finish it.
how many questions are on the final?
On the final, I haven't decided yet.
Please don't make it 25. Well, I know it's not
Less?
25.
50
No.
sounds good.
Yeah, give us a fair. If we miss.
Yeah,
Miss
so
about
if I
20.
miss 5, it's only
It's 25 too few
Too few.
It's.
for a regular exam?
No.
Yes, and
That's what I'm
yes,
used
and
to.
no.
A little bit.
I like bigger tests because there's like less points when you miss. When you make a
That's
mistake.
true.
When you inevitably cry when you.
That is
your
true.
Tears towards answer a long way.
But the more questions I ask, the more opportunity there is for you not to finish the test too.
That is true.
That is true.
And you've only got
That's why-
75 minutes.
I
That's why
am
it's
like
yeah.
the last one done.
So I figure about 3 minutes a problem is
Yeah.
about more than enough. So I don't want to make you feel overly rushed.
Yeah.
Yeah.
Like this one, it's like.
I always feel really rushed anyway, but I'm just also a test anxiety filled person, so.
And we have, what, 2 more exams after this and then the final, or 1 more exam and
I
then
think
the
one more
I
in the
think
final.
so.
Okay. Okay.
But I mean, think about it. What are you all earning for every quiz I'm taking?
Exactly. The quizzes really help, like, so I ain't gonna complain about those.
You said we didn't have to draw the dash and wedge. We asked you. You said if it's not drawn, we don't have to draw the dash and wedge.
And it's because it said it underneath, even though it wasn't drawn, it said S and N humor underneath it.
I didn't know what I was doing. I didn't know what I was doing.
But, I mean, every 5 quizzes is an exam. Right? So- And I set the floor, I didn't tell you all this, but I mean, the floor is set at 10. Right? So
The what?
the floor. I mean, if you missed everything but turned it in and tried it, you still get 10 points.
So like if we missed the quiz?
Not if you missed the quiz. If
Oh.
you turned it in and you completely got it wrong, but you attempted it,
Okay.
you would floor out at 10,
Okay.
not 0.
I ain't gonna complain.
Not turning it in is a 0.
I'm not complaining, but I'm complaining about not having the time to do anything. That's why I'm happy I have more time now this week.
Good. Good, good, good.
When I'm lab this week, so Tuesday from 9 to 9.
12 hours.
All right, I'll see you all tomorrow.
See you tomorrow.
Maybe you get a steak tea.
I'll try to get this uploaded before I go home.
I want to cut out the last 5 minutes of it.
Thanks, have a nice night.
Yes, you're welcome.
We watch videos. We read.
Crash course, Khan Academy.
Crash course.
Crash Course Khan Academy.
There's this crash course